The last glacial period, popularly known as the Ice Age, was the most recent glacial period, which occurred from c. 110,000 to 12,000 years ago. This most recent glacial period is part of a larger pattern of glacial and interglacial periods known as the Quaternary glaciation. For this point of view, scientists consider this ice age to be merely the latest glaciation event in a much larger ice age, one that dates back over 2 million years and is still ongoing. During this last glacial period, there were several changes between glacier advance and retreat. The last glacial maximum, the maximum extent of glaciation within the last glacial period, was approximately 22,000 years ago, while the general pattern of global cooling and glacier advance was similar. Local differences in the development of glacier advance and retreat make it difficult to compare the details from continent to continent. Around 13,000 years ago, the late glacial maximum began. Around 10,000 years ago marked the beginning of the Holocene geological epoch, which includes the Holocene glacial retreat. For the point of view of human archaeology, it falls in the Paleolithic and Mesolithic periods. When the glaciation event started, Homo sapiens were confined to Africa and used tools comparable to those used by Neanderthals in Europe and the Middle East and by Homo erectus in Asia. Near the end of the event, Homo sapiens spread into Europe, Asia, and Australia. Archaeological and genetic data suggest that the source populations of Paleolithic humans survived the last glacial period in sparsely wooded areas, and dispersed through areas of high primary productivity while avoiding dense forest cover. The retreat of the glaciers allowed groups of Asians to migrate to the Americas and populate them. Origin and definition. The last glacial period is sometimes colloquially referred to as the last ice age, though this use is incorrect because an ice age is a longer period of cold temperature in which ice sheets cover large parts of the Earth, such as Antarctica. Glacials, on the other hand, refer to colder phases within an ice age that separate into glacials. Thus, the end of the last glacial period is not the end of the last ice age. The end of the last glacial period was about 11,700 years ago, while the end of the last ice age has not yet come. Over the past few million years, the glacial-interglacial cycle has been paced by periodic variations in the Earth's orbit via Milankovitch cycles, which are thus the cause of ice ages. The last glacial period is the best-known part of the current ice age, and has been intensively studied in North America, northern Eurasia, the Himalaya and other formerly glaciated regions around the world. The glaciations that occurred during this glacial period covered many areas, mainly in the northern hemisphere and to a lesser extent in the southern hemisphere. They have different names, historically developed and depending on the geographic distributions. Fraser, Pinedale, Wisconsin, Ara, Wisconsin, Davensian, Midlandian, Wurm, Merida, Vikes, Vistulian, Valdai in Eastern Europe and Zyrianka in Siberia, Tanki Hue in Chile, and Otira in New Zealand. The geochronological late Pleistocene comprises the late glacial and the immediately preceding penultimate interglacial Pre-Iron. Overview. The last glaciation centered on the huge ice sheets of North America and Eurasia. Considerable areas in the Alps, the Himalaya and the Andes were ice-covered, and Antarctica remained glaciated. Canada was nearly completely covered by ice, as well as the northern part of the United States, both blanketed by the huge Laurentide ice sheet. Alaska remained mostly ice-free due to arid climate conditions. Local glaciations existed in the Rocky Mountains and the Cordilleran ice sheet and as ice fields and ice caps in the Sierra Nevada in northern California. In Britain, mainland Europe, and northwestern Asia, the Scandinavian ice sheet once again reached the northern parts of the British Isles, Germany, Poland, and Russia, extending as far east as the Taimyr Peninsula in western Siberia. The maximum extent of western Siberian glaciation was reached approximately 16,000 to 15,000 BCE, and thus later than in Europe. Northeastern Siberia was not covered by a continental-scale ice sheet. Instead, large, but restricted, icefield complexes covered mountain ranges within northeast Siberia, including the Kamchatka-Koyuk Mountains. The Arctic Ocean between the huge ice sheets of America and Eurasia was not frozen throughout, but like today probably was only covered by relatively shallow ice, subject to seasonal changes and riddled with icebergs carving from the surrounding ice sheets. According to the sediment composition retrieved from deep-sea cores, there must even have been times of seasonally open waters. Outside the main ice sheets, widespread glaciation occurred on the Alps-Himalaya mountain chain. In contrast to the earlier glacial stages, the WURM glaciation was composed of smaller ice caps and mostly confined to valley glaciers, sending glacial lobes into the alpine foreland. To the east, the Caucasus and the mountains of Turkey and Iran were capped by local ice fields or small ice sheets. In the Himalaya and the Tibetan Plateau, glaciers advanced considerably, particularly between 45,000–25,000 BCE, but these datings are controversial. The formation of a contiguous ice sheet on the Tibetan Plateau is controversial. Other areas of the Northern Hemisphere did not bear extensive ice sheets, but local glaciers in high areas. Parts of Taiwan, for example, were repeatedly glaciated between 42,250 and 8,680 BCE, as well as the Japanese Alps. In both areas, maximum glacier advance occurred between 58,000 and 28,000 BCE. To a still lesser extent, glaciers existed in Africa, for example in the High Atlas, the mountains of Morocco, the Mount Atacor Massif in southern Algeria, and several mountains in Ethiopia. In the southern hemisphere, an ice cap of several hundred square kilometers was present on the East African mountains in the Kilimanjaro Massif, Mount Kenya and the Rwenzori Mountains, still bearing remnants of glaciers today. Glaciation of the southern hemisphere was less extensive because of current configuration of continents. Ice sheets existed in the Andes, where 6 glacier advances between 31,500 and 11,900 BCE in the Chilean Andes have been reported. Antarctica was entirely glaciated, much like today, but the ice sheet left no uncovered area. In mainland Australia, only a very small area in the vicinity of Mount Kosciuszko was glaciated, whereas in Tasmania glaciation was more widespread. An ice sheet formed in New Zealand, covering all of the Southern Alps, where at least 3 glacial advances can be distinguished. Local ice caps existed in Irian Jaya, Indonesia, where in 3 ice areas remnants of the Pleistocene glaciers are still preserved today, named local glaciations. Antarctica glaciation. During the last glacial period, Antarctica was blanketed by a massive ice sheet, much as it is today. The ice covered all land areas and extended into the ocean onto the middle and outer continental shelf. According to ice modeling, ice over Central East Antarctica was generally thinner than today. Europe-Devensian and Midlandian glaciation. The name Devensian glaciation is used by British geologists and archaeologists and refers to what is often popularly meant by the latest ice age. Irish geologists, geographers, and archaeologists refer to the Midlandian glaciation as its effects in Ireland are largely visible in the Irish Midlands. The name Devensian is derived from the Latin Devenses, people living by the Dee, a river on the Welsh border near which deposits from the period are particularly well represented. The effects of this glaciation can be seen in many geological features of England, Wales, Scotland, and Northern Ireland. Its deposits have been found overlying material from the preceding Ipswichian stage and lying beneath those from the following Flandrian stage of the Holocene. The latter part of the Divensian includes pollen zones IV, the Allerod and Bowling oscillations, and the older and younger Dryas climatic stages. Vikes glaciation. Alternative names include Glacial glaciation or Vistuluan glaciation. Evidence suggests that the ice sheets were at the maximum size for only a short period, between 25,000 and 13,000 BP. 8 interstadials have been recognized in the Vikes, including the Oral, Glind, Moa-Shuford, Henglo and Dienekamp. However, correlation with isotope stages is still in process. During the glacial maximum in Scandinavia, only the western parts of Jutland were ice-free, and a large part of what is today the North Sea was dry land connecting Jutland with Britain. It is also in Denmark that the only Scandinavian Ice Age animals older than 13,000 BC are found. The Baltic Sea, with its unique brackish water, is a result of meltwater from the Glacial glaciation combining with salt water from the North Sea when the straits between Sweden and Denmark opened. Initially, when the ice began melting about 10,300 BP, seawater filled the isostatically depressed area, a temporary marine incursion that geologists dubbed the Yoldia Sea. Then, as post-glacial isostatic rebound lifted the region about 9,500 BP, the deepest basin of the Baltic became a freshwater lake, in paleological contexts referred to as Ancillus Lake, which is identifiable in the freshwater fauna found in sediment cores. The lake was filled by glacial runoff, but as worldwide sea level continued rising, salt water again breached the sill about 8,000 BP, forming a marine littorina sea, which was followed by another freshwater phase before the present brackish marine system was established. At its present state of development, the marine life of the Baltic Sea is less than about 4,000 years old. Drs. Thulin and Andrushaitis remarked when reviewing these sequences in 2003. Overlying ice had exerted pressure on the Earth's surface. As a result of melting ice, the land has continued to rise yearly in Scandinavia, mostly in northern Sweden and Finland, where the land is rising at a rate of as much as 8 to 9 millimeters per year, or 1 meter in 100 years. This is important for archaeologists since a site that was coastal in the Nordic Stone Age now is inland and can be dated by its relative distance. For the present shore, WURM glaciation. The term WURM is derived from a river in the Alpine foreland, approximately marking the maximum glacier advance of this particular glacial period. The Alps were where the first systematic scientific research on ice ages was conducted by Louis Agassiz at the beginning of the 19th century. Here, the WURM glaciation of the last glacial period was intensively studied. Pollen analysis, the statistical analysis of microfossilized plant pollens found in geological deposits, chronicled the dramatic changes in the European environment during the WURM glaciation. During the height of WURM glaciation, c. 24,000–10,000 BP, most of Western and Central Europe and Eurasia was open-steppe tundra, while the Alps presented solid ice fields and montane glaciers. Scandinavia and much of Britain were under ice. During the WURM, the Rhone Glacier covered the whole western Swiss plateau, reaching today's regions of Solothurn and Aarau. In the region of Bern it merged with the Aar Glacier. The Rhine Glacier is currently the subject of the most detailed studies. Glaciers of the Reuss and the Limit advance sometimes as far as the Jura. Montane and Piedmont glaciers formed the land by grinding away virtually all traces of the older Gunz and Mindel glaciation, by depositing base moraines and terminal moraines of different retraction phases and loess deposits, and by the proglacial rivers shifting and redepositing gravels beneath the surface. They had profound and lasting influence on geothermal heat and the patterns of deep groundwater flow. North America. Pindale-Fraser Glaciation. The Pindale-Fraser Glaciation was the last of the major glaciations to appear in the Rocky Mountains in the United States. The Pindale lasted from approximately 30,000 to 10,000 years ago and was at its greatest extent between 23,500 and 21,000 years ago. This glaciation was somewhat distinct from the main Wisconsin glaciation, as it was only loosely related to the giant ice sheets and was instead composed of mountain glaciers merging into the Cordilleran ice sheet. The Cordilleran ice sheet produced features such as Glacial Lake Missoula, which would break free from its ice dam, causing the massive Missoula floods. USGS geologists estimate that the cycle of flooding and reformation of the lake lasted an average of 55 years and that the floods occurred approximately 40 times over the 2,000-year period between 15,000 and 13,000 years ago. Glacial lake outburst floods such as these are not uncommon today in Iceland and other places. Wisconsin glaciation. The Wisconsin glacial episode was the last major advance of continental glaciers in the North American Laurentide ice sheet. At the height of glaciation, the Bering Land Bridge potentially permitted migration of mammals, including people, to North America from Siberia. It radically altered the geography of North America north of the Ohio River. At the height of the Wisconsin episode, glaciation ice covered most of Canada, the upper Midwest, and New England, as well as parts of Montana and Washington. On Kelly's Island in Lake Erie or in New York's Central Park, the grooves left by these glaciers can be easily observed. In southwestern Saskatchewan and southeastern Alberta, a suture zone between the Laurentide and Cordilleran ice sheets formed the Cypress Hills, which is the northernmost point in North America that remained south of the continental ice sheets. The Great Lakes are the result of glacial scour and pooling of meltwater at the rim of the receding ice. When the enormous mass of the continental ice sheet retreated, the Great Lakes began gradually moving south due to isostatic rebound of the North Shore. Niagara Falls is also a product of the glaciation, as is the course of the Ohio River, which largely supplanted the Priates River. With the assistance of several very broad glacial lakes, it released floods through the gorge of the upper Mississippi River, which in turn was formed during an earlier glacial period. In its retreat, the Wisconsin episode glaciation left terminal moraines that form Long Island, Block Island, Cape Cod, No Man's Land, Martha's Vineyard, Nantucket, Sable Island and the Oak Ridges moraine in south-central Ontario, Canada. In Wisconsin itself, it left the Kettle moraine. The drumlins and eskers formed at its melting edge are landmarks of the lower Connecticut River Valley. Tahoe, Tenaya, and Tioga, Sierra Nevada. In the Sierra Nevada, there are three named stages of glacial maxima separated by warmer periods. These glacial maxima are called, from oldest to youngest, Tahoe, Tenaya, and Tioga. The Tahoe reached its maximum extent perhaps about 70,000 years ago. Little is known about the Tenaya. The Tioga was the least severe and last of the Wisconsin episode. It began about 30,000 years ago, reached its greatest advance 21,000 years ago, and ended about 10,000 years ago. Greenland glaciation. In northwest Greenland, ice coverage attained a very early maximum in the last glacial period around 114,000. After this early maximum, the ice coverage was similar to today until the end of the last glacial period. Towards the end, glaciers re-advanced once more before retreating to the present extent. According to ice core data, the Greenland climate was dry during the last glacial period, precipitation reaching perhaps only 20% of today's value. South America. Merida glaciation. The name Merida glaciation is proposed to designate the alpine glaciation which affected the central Venezuelan Andes during the late Pleistocene. Two main moraine levels have been recognized, one between 2,600 and 2,700 meters, and another between 3,000 and 3,500 meters elevation. The snow line during the last glacial advance was lowered approximately 1,200 meters below the present snow line. The glaciated area in the Cordillera de Merida was approximately 600 square kilometers. This included the following high areas from southwest to northeast: Páramo de Tama, Páramo Batalan, Páramo Los Conejos, Páramo Piedras Blancas, and Teta de Niquiteo. Approximately 200 square kilometers of the total glaciated area was in the Sierra Nevada de Merida, and of that amount, the largest concentration, 50 square kilometers, was in the areas of Pico Bolivar, Pico Humboldt, and Pico Bompland. Radiocarbon dating indicates that the moraines are older than 10,000 years BP, and probably older than 13,000 years BP. The lower moraine level probably corresponds to the main Wisconsin glacial advance. The upper level probably represents the last glacial advance. Tanki Hue Glaciation. The Tanki Hue Glaciation takes its name from Tanki Hue Lake in southern Chile, which is a fan-shaped Piedmont glacial lake. On the lake's western shores there are large moraine systems, of which the innermost belong to the last glacial period. Tanki Hue Lake's valves are a node point in southern Chile's valve geochronology. During the last glacial maximum, the Patagonian ice sheet extended over the Andes from about 35 degrees south to Tierra del Fuego at 55 degrees south. The western part appears to have been very active, with wet basal conditions, while the eastern part was cold-based. Cryogenic features like ice wedges, patterned ground, pingos, rock glaciers, pulses, soil cryoturbation, solifluction deposits developed in unglaciated extra-Andean Patagonia during the last glaciation. However, not all these reported features have been verified. The area west of Tanki Hue Lake was ice-free during the LGM, and had sparsely distributed vegetation dominated by Nothofagus. Valdivian temperate rainforest was reduced to scattered remnants in the western side of the Andes.